Charmaine is going to explain what you do. Guys, be quiet. Charmaine, go ahead.
Well, step one is to establish your claim. H naught is mu1 equals mu2. H1 is mu1 not equals mu2, which is your claim.
How do you know it's that?
Because it says so over there.
Over where?
That the mean weight of males is different from the mean weight of females. Could it be concluded?
Does that make sense? Concluded that the mean weight is different. So different means not equal. Great.
So it's a two-tailed test. Then the second, step number 2 is to get your critical value. So our alpha is 0.05. Since this is a mean test, it's for mean and not the proportion, you need your degrees of freedom. You need to get the smaller population, which is 8. So 8 minus 1 is 7. And if you look in the in our table, in our T table, that's the critical value is positive negative 2.365. So you draw it. And then step 3 is to do the test stat. That's the formula. You plug in the numbers. And then I used the calculator. I did 2 sample t-tests and I got 2.27. So that's lower than my, it's lower than 2.365. So in step 4, that means we cannot reject H naught.
Remember, step 4 is all about H naught. Rejecting it or not rejecting it. You're always going to use, either going to reject H naught or fail to reject H naught.
Yes.
Great.
And then so 5, there is not enough evidence to support the claim that average weights of newborn males differ from females.
Great. Questions? You guys want 15 seconds to check with your neighbors? No?
No, we're good.
Good. Okay. Everybody's good?
Yep.
All right. Good. Now, using the formulas for confidence intervals for the difference between two means. Again, you're going to take your x bar 1 minus x bar 2, and you're going to add or subtract your error. This is your critical value. And like I said previously, they're not very useful, I don't think. So instead, the next page, right? Where it says confidence intervals at the top. Leave the formulas because they're fine. There's nothing wrong with them, right? But these 2 parts, the example and the lab problem 5, just a little X through those because we're not going to do those.
Woohoo! Nice work.
Good? Okay. So now we're on to the next page. Means of 2 dependent samples. Matched pairs. Okay. So here's the deal. These can be really, really, really easy if you focus for the next 3 minutes. They'll be a piece of cake. Otherwise, they'll be totally confusing and complicated, and you'll have no idea what to do with them. So it's 3 minutes. Dependent samples, they're matched pairs. They're all matched up. So in other words, they're always in pairs. So here is the height of a president and the height of his opponent. Here's the height of another president and the height of his opponent. The height of another president and the height of his opponent. They go together. So 189 goes with 170. I can't put 189 with 175 because that wasn't the height of his opponent. Do you guys follow me? They go together. Since they all belong together, then all we have to do is find their difference because we care about the difference between them. So all we care about is the difference between these. So 189 minus 170 is 19. This is negative 12. That's 8. That's 0. That's 1. These are what we call the little d's, the differences. Once you see them in matched pairs like this, where they go together, then you just find their difference. They have to go together. So it's like somebody's right arm compared to their left arm, right? Or siblings, like Audrey compared to her sibling, right? Ayla compared to her sibling. You got to match them up and compare them. then like I said, once you find the differences, then it's just a regular single sample t-test on these numbers there. That's all it is. Super straightforward. So we're just going to take these numbers and run a one sample t-test on it. Very, very, very straightforward. Let's talk about it just a little bit, a couple of pieces. Here's some notation. How about, you guys can talk. Alicia, go ahead. Yeah.
Individual differences between the two values of a single matched pair, mu,
Mu D.
mu d, the mean value of the differences d for the population of all matched pairs of data. Bar.
D bar.
Oh, d bar means value of the differences d for the paired sample data.
Right, so it's kind of like your X bar, well it's D bar. If you average all those little differences, it's just their average, their sample mean. Right, so it's, you can kind of think of it as like X bar D if you want. Keep going.
Sample d.
SD.
Standard deviation of the differences d for the paired sample data and number of pairs of sample data.
Great. So you could look at, you could maybe think of this as being your, kind of like your X bar sub D if you want, if that's easier. Right, that's a little bit simpler to think about. Here's some basic requirements. The sample data are dependent. In other words, what you pick the first group totally determines who you pick for the second group. Right, so if I pick you guys for the first group, I've got to, if I pick your right arms for the first group, then I have to pick your left arms for the second group. And I got to match them up. Next, samples are simple random samples. The first group has to be randomly selected. And then, again, like always, either the data has to be normally distributed, or your sample size has to be 30 or more. Good. So pretty much what I'm going to say is assume the data is normally distributed. Right? You're going to get a sample size less than 30. Okay, so the hypothesis test, it's very, very similar. Your test set is very, very similar to your single sample. I'm going to look at your single sample one here. Hypothesis test, one mean. These are means. One mean. Do you guys see it up here? T equals X bar minus mu over S over square root of N. This is almost the same, only X, instead of X bar, it's D bar. So you kind of really think of that as X bar sub D if you want. Right? The only catch is RH naught is that the differences is equal to 0. So in other words, you take the two samples and you subtract them, it's equal to 0. Which means that this is going to be 0. So it's even easier, really, in a sense. It's even simpler than the regular one, because you're saying that their differences are 0.
So it's only D bar over.
What was that?
So basically it's D bar over S.
Yeah, it totally is. Here's an example. We'll kind of walk through it. It'll be easier. So here, I found all the differences between these two. And here I'm saying that the differences, I'm saying that the heights are higher, the heights of the president is higher than their opponents. So I'm saying that mu1 is greater than mu2. Do you guys kind of see what I'm saying?
Yeah.
But really, in terms of this works out to being that ud is greater than 0. The difference is, when you subtract that, is greater than 0. If I said the opposite, then if I wanted to say that mu1 is less than mu2, then I'd say that the difference is less than 0. Do you guys see what I'm saying?
Okay.
But I'm saying the heights of the presidents are higher than their opponents. So their difference is positive. In other words, mu1 is, when you subtract them, mu1 is minus mu2 is going to be positive. So their height, so mu d would be greater than 0, would be saying that mu1 is bigger than mu2. Everybody all right with that part? Okay. So let me go ahead and start with my H naught. H naught, step 1, is that mu d is equal to 0. H1, I'm saying that the first one's larger than the second one, so when I subtract them, the differences should be larger than 0. Positive. Step 2, critical value. Ooh, look that up in the table. Let's see. What's my n? How many of these things do I have?
5.
Remember, we're just looking at these guys here. Right? We no longer care about this stuff. Do you guys understand what I'm saying?
Yeah.
Once we found the differences, we don't care where they came from. Now we only care about these guys. So we're saying that my degrees of freedom is equal to 5 minus 1, because there's 5 of these. And what was my alpha? 0.05?
Yep.
I'm saying greater than, so I'm over here.
1
Greater than, 1-tailed. So alpha's 0.05. So I'm going to look at my little sheet here. 1-tailed test, that's the bottom row here. Alpha's 0.05. Degrees of, second column, degrees of freedom 4. I get 2.132. Is that what you guys got?
Yeah.
Okay, great. 2.132. Perfect. Now, I need to figure out what my test stat is. So I'm going to look up on here, and I'm going to go to that one. X bar 1 minus mu naught over S over square root of n. So really, it's not X bar 1. It's really, in a sense, well, it's fine. X bar sub d. So this is 0. So this becomes,
X bar D.
oh, I know what to do. So now, I need to figure out what these things are. Ooh, I need my S and my X bar D. So I need to go to,
Test. Start edit.
let me clear this so that I don't end up with what we had in there from before. Stat, edit, and I'm going to put them in. What do I have? I have 19. I have negative 12. Don't forget, you have to use this little minus sign by the enter to get your negative. Negative 12. What else do I have? 8,
8.
0, 1. And I'm going to go to stat,
1 bars.
calc, 1 bar stats. As long as I put it into L1, I just hit enter, or I can do second L1 or whatever list I have it in. And now I have gives me my X bar, which is really my X bar sub D, and my SX, my sample standard deviation, S. So I've got my X bar D is,
3.2.
I'm going to write these over up to the side. I knew that my X bar D is equal to 3.2, and my SD is equal to 11.4. All right, now I can plug them in. 3.2 over 11.4 over square root of 5. We got 5 of them. That's pretty easy to calculate. Do the bottom first and then do the top. So I'm going to do 11.4 divided by square root of 5. That's going to give me 5.098 on the bottom, and the top is going to be 3.2. So 3.2 divided by 5.098, and we'll get 6.28. You round? Or 0.628, sorry. 0.628. You can also, if you want want to do, you can do stat test. So I could have done stat test.
Mm-hmm.
What is this, guys?
T-test.
Just regular t-test, because, guys, focus. We've taken 2 samples and we subtracted them to get 1 sample.
Mm-hmm.
So now we only have 1 sample. It's just a regular 1 sample t-test.
Mm-hmm.
So we're going to do t-test on this one. And we can use data, because all my data is in there. It's in list 1. All my differences are in there. My mu naught is 0. List is in L1. Frequency is 1. And I want less than? Greater than.
Greater than.
Calculate. And boom. Yep, 0.628. Same thing. So I'm going to throw it in there. Please note, here's my middle. It's positive. It should still be the right side. Don't throw it over here somewhere. Okay,
Yep.
stick it at least on the right side. 0.628. So my test stat. So am I going to reject H naught or fail to reject H naught?
Do not reject.
Yeah, do not reject. It's totally not in the guilty region. There's not enough evidence at all. Do not reject H naught. Step 5. Not enough oh, sorry. Do I have enough evidence?
No.
Yeah. Not enough evidence?
To support.
Yep. 2. And then my claim is H1, so I'm going to use the word support. Claim that,
Difference.
yeah, heights and presence are taller than opponents. So the only things, and you might want to, on your notes, you're going to want to make a couple quick notes. One is, if it's a 2 sample dependent, it's a matched pair. That's the first thing you're going to talk about. Second thing you should note is that you subtract them to get their differences. And then you run a 1 sample t-test on those differences. The other thing you should notice is that your mu naught is always going to be 0 for this then. Mu naught's always going to be 0. 99% of the time it's going to be 0, and 100% of the time in this class it will be 0. So in other words, it's going to be mu d equals 0. Good?
Yes.
All right. You guys do your problem. Oh, you know, we should talk a little bit. Do you guys want to talk a little bit about lab problem 7 first before we do that?
Yes.
Okay. Then we can kind of wrap up with that. So lab problem 7, I'm going to bust it out. Here it is. Yes, it's due Thursday. It's due in a couple days. However, you can turn it in late for full. Oops. You can turn it in late for full credit on the following Tuesday. Good. Okay. I screwed up, and you guys only have to do 1.
Yay.
It needs to be a mean.
Mean.
So you have 4 questions you picked. 2 of them are numerical. You took a picture of them in the beginning of the semester, right? So choose one of the ones that you chose. So who can think of one of their questions? Yeah, Daniel, what's your question?
Average age.
Average age, great. So, see this one, it says, what is your age? He has to pick one of these claims. That the average age is less than 25, or equal to 25, or greater than 25. One of those has to be his claim. Do you guys understand what I'm saying?
Yes.
He's going to do a hypothesis test upon that. Who else can remember one of theirs? One of their questions?
How many hours of
Average
sleep?
sleep hours.
Sleep hours, great. So then, how many hours do you sleep? That must be down here somewhere. Yep, on average. So you have to say, you have to pick ones for your claim. Either that the average hours of sleep is greater than 7, less than 7, or equal to 7. You gotta pick one of those for your claim. Everybody on board?
Yes.
Great. Once you pick that, you can neatly write it if you want, or you can type it, I don't care. So the first thing is, state your claim about your chosen parameters. So if you look at the top, I've given you a sort of a hint. For example, those who knew LPC college, community college students work an average of less than 25 hours a week. Or you might say, have an average age of greater than 25. Or sleep more than 7 hours a week. Whatever it is that you, whatever you've kind of chosen. Good? Then, you have to state what kind of distribution you're going to use for this. Is it going to be a Z or a T? That's not your choice. It's a mean. So what should you use for this mean? Z or T? Don't say it, just you know, right?
Yes.
State that. Say the requirements and whether your data fulfills the requirements. So go back to project part 6. Remember we had that part in the very top of the page of project part 6? It says, and you'll say, my data fulfills the requirements because, and it's the mean one. So it's stuff like, my sample is a simple random sample, and my sample size is more than 30. And then you're going to get to the regular stuff. Conduct your hypothesis test. So that's why I want those 5 steps that you always do that you guys are familiar with now, right? Step 1, state your H0 and your H1 and identify which one's your claim. Step 2, find your critical value, draw a picture. Step 3, find the test stat for your sample. Right, you have a sample mean and a sample standard deviation. So you should probably use the one you just did in your confidence interval, because you have the mean and standard deviation from that. So I'd pick that one. And then step 4, figure out whether or not you're going to reject H0. And step 5, summarize for your claim. Good? Neatly written or typed, I don't care. Hand it in on Thursday. You can turn it in late for full credit the following Tuesday. Good. Now, I would like you to work on problem number, I don't know where it is. Where is it? There we go. Let's do this to be consistent with last class. Let's just do step 1 and 3. Step 1 and step 3.